Long time no see. I got a lot buffer since we last seen each other. Do you like it?
Now let's zoom into his skin.
Whoa, what?
Alright, now that we're inside him, let's look at the stratum corneum. This refers to the outermost dead layer of the epidermis, which is the top layer of the skin. It acts as the body's primary barrier against environmental damage, pathogens, and dehydrations. This barrier is made of comiocytes, which are specialized dead skin cells. They are nucleus-free, flattened, and contain creatine filaments surrounded by proteins and lipids to provide physical protection. They form a structure often described as brick and mortar, where the comiocytes are bricks and the lipids act as the mortar. Now let's talk about desquamation. This process refers to the natural and constant shedding of the outermost layer of skin, stratum corneum. As the process is natural, it should not cause discomfort. Desquamation is often triggered by skin damage, infections, or other inflammations. Other factors can increase the rate of desquamation, such as environmental factors like sunburn, UV rays, windburn, hypothermia or extreme cold, and dry air. Skin conditions like eczema, psoriasis, along with genetic disorders like peeling skin syndrome can also affect the rate of one's natural rate of desquamation and increase the feeling of irritation. Finally, for the physical barrier side of things, let's talk about tight junction proteins. Tight junction proteins are transmembrane proteins that directly connect adjacent cell membranes. This creates a veil between two cells to prevent any leakage through cell membranes. In skin, they form a crucial seal-like barrier against water loss and pathogens. Now onto the chemical barrier, we have the acid mantle. The acid mantle is a very thin and slightly acidic film ranging from a pH level of 4.5 to 6.2 that is composed of sebum, sweat, and fatty acids. Sebum is produced by the sebaceous glands containing triglycerides and fatty acids that contribute to the oily protective layer. Sweat is produced by sweat glands containing lactic acid and amino acids which help establish the acidic environment. This mantle maintains an acidic environment for the beneficial bacteria to survive and the harmful ones to be inhibited. Then we have antimicrobial peptides and lipids. On the skin, humans have small amphiphilic molecules that act as the first-line innate immune defense against pathogens. They are produced by keratinocytes, the primary type of cell found in the epidermis. The antimicrobial peptides and lipids function together as innate immune defenders on the skin by targeting and disrupting microbial membranes that cause lysis. Now to the mucous membrane. These membranes serve as the first line of defense in areas without skin. They are moist, protective tissue that line the body cavities exposed to air, abrasive particles or bodily fluids, and invasive pathogens. They are located in the respiratory system, such as the nostrils, nasal cavity, throat, trachea, bronchi, and lungs. The digestive system, such as the mouth, esophagus, stomach, intestines, and anus. And the urogenital system, such as the uterus, urinary bladder, urethra, and genital tract. The mucous membrane, also referred to as the mucosa, has 3 layers. Before the 3 layers, however, we can't forget about the mucus. Okay, now on to the epithelium. Epithelium is the surface layer of cells. They secrete a thick, gel-like mucus that protects the body. These cells have a high turnover rate, meaning that they replace themselves often when clearing out invasive particles and pathogens. Some may have cilia, which help move foreign substances, such as the case in the lungs. Next layer is the lamina propria. Epithelium attaches to loose connective tissue. lamina propria. This is the middle layer that is composed of structural protein nerves and veins. It carries blood supply to the epithelium while holding them in place and binding them to smooth muscle below. It hosts a variety of immune cells within to seek and destroy pathogens. The muscularis musca, which is the last layer, which is the deepest layer of the mucosa, and it's a layer of smooth muscle. This helps the mucosa to stretch and contract along various organs, along with cleansing functions by keeping cilia in motion. And finally, there are blood clotting cascades. There are three main pathways that the clotting cascade can follow, aka the clotting pathway. The extrinsic and intrinsic pathway act as different starting points that result in the common pathway. First off, the extrinsic pathway begins with tissue fluid of factor 3(3), is exposed because of bleeding or found outside of the blood. When bleeding occurs, a protein called tissue factor is activated. This activates factor 7, or 7A, to which activates factor 10, or 10A, leading to the intonation of the common pathway. The intrinsic pathway starts with factor 11. The collagenation starts from inside the blood. When bleeding occurs, factor 11 is activated, or factor 11A. This activates factor 9, or factor 9A, which joins with factor 8, or factor 8A. This joint factor activates factor 10, or 10A, which will begin the common pathway. The common pathway is a pathway that starts as a result of either the intrinsic or extrinsic pathway activating factor 10 or X. Activated factor 10 or 10A joins with activated factor 5 or 5A. Together, these factors turn prothrombin into thrombin. Thrombin changes fibrinogen into stick fibrin, which helps to make a strong clot.
All natty, by the way. Just so you know.